This is Britt Caswell with another example video. In this video, I'm covering example 2 from lesson 2-1 in the SavvasRealize Algebra 2 textbook. This example covers the key features of a quadratic. So when I first saw this example, I said, well, what are they considering the key features? Because there's a lot of different pieces to the graph. Okay, so I tried to think about as many of them as possible. Okay, we're going to look at x-intercepts, the y-intercept, the vertex, which is often called the minimum or maximum, the axis of symmetry, which is that imaginary dotted line which a parabola is symmetric about, the domain, and the range. So here we go. So the x-intercepts. Right, we can tell just based off graphing this quadratic, there are none. Okay, but I want to tell you about how to figure that out just from the equation. So this equation is written out in vertex form, right? Which means that our vertex lies at the point HK. So if I think about the vertex form and how it's usually looking, right? I have a times x minus h squared plus k. I could quickly determine the vertex here, which will matter here in just a moment. So remember, h is the value being subtracted from x, so the number being subtracted from x here is 3. My k value is whatever is happening at the end. Okay, in this case it's an addition of 4. So the vertex of this parabola is at 3, 4. So what does that have to do with the x-intercepts? Recall that this a value, this tells you how much the parabola moves up or down when you move 1 unit to the side. So if I know I have a parabola with a vertex at 3, 4, which is above the axis, and I have a positive a value, right, here it's when I go 1 to the side, I go 2 up, I know this parabola is going to continue going up for forever. So just looking at that equation, I could tell you that it's not going to ever cross. Now, if that a had been negative, then heck yeah, that would have been going down, and it would go down for forever. Now, the axis of symmetry is another one that's really easy, and the axis of symmetry lies at x equals h. Okay, remember that the axis of symmetry is a line. So when we describe the axis of symmetry, it has to be done with an equation. So in this case, it's x equals 3. Alright, so now the y-intercept. Okay, now recall the y-intercept is where the graph is crossing this y-axis. So anywhere on this y-axis, my value of x is 0. So to find my y-intercept, all that I have to do is evaluate the function when x equals 0. So everywhere there's an x, which is just in one place, I plug a 0. In terms of simplifying, right here, 0 minus 3 is negative 3. I square that to get 9 and multiply it times 2 to get 18. Okay, so when my function has a 0 plugged in, my y value is 22. So that y-intercept is at the point 0, 22. In terms of domain and range, parabolas tend to continue to go outwards for forever, right? This parabola will move in that direction. I mean, it'll very slowly move outwards, but it doesn't stop. So what that means is that it will forever continue towards infinity and towards negative infinity on the x-axis. So the domain here is all real numbers. Or if you're using interval notation, from negative infinity to infinity. Now the range is what is restricted, right? It's our values on the y-axis. So if I'm considering this graph, okay, the lowest y value is here at 4, and it's inclusive at 4, so I'm going to put a bracket because this is a filled in circle. And then our graph continues to go up for forever towards positive infinity on the y-axis. Right? So those are our most important features. So part 2 here, I'm going to do this without the aid of a graph, just so that you guys can see some of the more interesting details. So again, the domain on a parabola, unless you have a word problem that restricts that domain, is all real numbers. So that's a very quick answer. This is written in vertex form, so that vertex is going to be very quick, right? Recall that the vertex is at hk. So our vertex for this one is at -4, -5. And the axis of symmetry is just at x equals h. So x equals -4. So if I'm doing like a mental sketch in my head, I know that going back by 4, I have this axis of symmetry, and down by 5, I have my vertex. So now check out your a value. Here our a value is negative. So that means that this parabola will open downwards. So because our vertex is below the x-axis, it's in the negative y values, and there's a negative a, there will be no x-intercepts. There is a y-intercept though, right? And we know how to calculate that. Remember, your y-intercept is when you plug in 0 into the function. Here we go. So f of 0. 0 plus 4 is 4. Square that is 16, and then there's a negative in front of it. So when I plug in 0, I get -21. So my y-intercept is at 0, -21. And our last thing to think about is the range. Remember, that's where it's on the y-axis. So we know this started at -5 on the y-axis, which was inclusive. And this parabola continues going downward for forever, so it goes towards -infinity. But recall, this is kind of backwards, isn't it? Because we always want to talk about the smallest y value and then the largest one. So you might be tempted to say, oh, this is where the parabola has a maximum. But just remember, you have to go from the bottom of the graph up, or else you'll be backwards. Okay? Another thing they do is they tell you to identify a minimum or a maximum, and I'll show you guys on both of these. Okay? And you're just picking which one is the minimum or the maximum. So on this parabola, because it opens facing down, this vertex is at a maximum. Our first example was facing upwards, right? So this vertex is actually a minimum. So your quadratic will have either a minimum or a maximum, and it's talking about the y value of the vertex. Okay? So I would say this parabola has a maximum of -5. Okay, so when they talk about min and max, it's always going to be describing the y value of the vertex. But there we go. There's some of the key features of our quadratic. Until next time.